Hello, my name is Piravin Thiran and Analaki Sri Thiran and my matrix number is B091810023. I am here today to be talking about my PSM1 project titled Wireless Engine Valve Crack Monitoring. Before I continue my presentation, I would like to thank my supervisor Mr. Noor Azazi Ben Natiman for helping me throughout the completion of this project, and I would also like to thank my examiners panel. First, let's look at the introduction of this project. Now let's look at the background of this project. At present time, engine valves is one of the most major components present in an engine. Engine valve plays a vital role in an engine's performance and is a mechanical component that is located in the cylinder head above the combustion chamber. Being one of the major parts of an engine, the engine valve is expected to maintain its shape, dimension, and strength throughout a valve's lifespan. Engine valves experiences high temperatures and gas pressure impulses during engine operation. Due to this, engine valve experiences wear, cracks, burns, and bending. So this project focuses on measuring the vibration signal produced by the cracked engine valve during engine operation. Now, let's look at the project's problem statement. Sinnasamy and his colleague states that engine experiences common faults such as abnormal fuel injection, abnormal valve clearance, misfire, fault piston ring, and broken rocker up. Another fault that usually occurs in an engine is the engine valve crack, where it can range from minuscule cracks to small size cracks. Due to these cracks, vibrations of the valve will increase, which directly increases the engine vibration level as well. This may eventually lead to complete engine failure or breakdown. This project focuses on these cracked engine valves and the vibration that they produce when they operate in an engine. As premium quality and long lifespan is required by automobile manufacturers to be competitive in the automobile market. It is important that vibrations produced by an engine operation is measured and analyzed, where the analysis can be used to reduce and possibly eliminate the vibrations, ensuring quality, parts lifespan, and car ride comfort. Next, let's look at the objectives of this project. Based on the background and problem statement which have been stated, there are three objectives for this project, which are number one, to measure the engine valve vibrations under normal and cracked condition wirelessly. Number two, to utilize statistical analysis methods to analyze the measured valve vibration signals. Number three, to verify the analyzed engine valve vibration signals to the method of machine learning. Next, let's look at the project scope of this project. This project aims to produce a hardware that is Arduino based to measure the engine valve vibration signals under normal and abnormal conditions utilizing the piezoelectric vibration sensor wirelessly. The measured vibration signals will then be analyzed through the various statistical analysis methods. Then the valve vibration signals analyzed are validated through machine learning via the MATLAB software through the fast Fourier transform method. Now, let's look at the literature review of this project. There are three major parts of this project's literature review. These three parts are vibration, car engine, and finally condition monitoring. First, let's look at the vibration part of the literature review. This part is divided into three subparts, which are classification of vibration, parts of a vibration system, and vibrations in a vehicle. In this part, it is found that the motion of displacement from the point of equilibrium for a system of connected bodies or component or particle is called vibration. Vibrations usually occur if a system is displaced from its equilibrium where it moves to and fro through its equilibrium point. An engine is the main source of vibration caused by loosening of mounts. Even though engine is the main source of vibration, there are other vehicle components that also contribute to the vibrations such as suspension, wheels, road condition, and so forth. In this part also, it was found that force vibration exists for two states of excitation, which are determining excitation and random excitation. Engine valves produces forced vibration due to defects such as improper clearance, loose fittings, cracks, and misalignment. Engine vibrations have a drastic effect on the performance of the engine, where it can cause a reduction in the fuel consumption efficiency and may lead to noise pollution. Due to this, the valve's vibration under cracked and normal conditions were chosen to be monitored in this project. The next part of the literature review is the car engine part. This part is divided into three subparts, which are basic parts in a car engine, gasoline engine, and defects present in an engine. It was discovered that the main purpose of an engine is to provide power to move the car forward or backwards. An engine is a complex component which consists of pistons, gears, crankshafts, valves, etc. It is also known that the basic parts of the engine were the engine block, cylinder head, piston and piston ring, camshaft, spark plug, and valves. Besides that, it was found that engine defects usually occur on the components such as valve, cylinder head, pistons, and valve train. As the valve train also includes another component that causes engine defect, which is the valves, it is safe to say that the valve train are one of the major contributors to engine defects and vibrations. Valve train faults result in performance and reliability reduction. The high temperatures are responsible for decrease in the valve material's yield strength and hardness. The next figure shows an example of a valve crack. The next part of the literature review is the condition monitoring part. This part is divided into four sub-parts, which are vibration analysis, statistical analysis, machine learning, and fault diagnosis. Condition monitoring is the process of monitoring the parameters of an equipment or machinery or structure where significant change in the parameters are monitored to indicate defect or failure. Vibration analysis is a condition monitoring technique. Besides that, statistical analysis methods will be utilized as the project requires input of data obtained from signal acquisition of the engine valves during engine operation. It requires statistical analysis to analyze and interpret the data collected. It was then found that machine learning can be done through the MATLAB software. Finally, it's found that proper fault diagnosis carried out on automobile engines help to reduce unwanted accidents by providing early warnings. Fault diagnosis is performed on the engine via vibration analysis from the vibration signals produced by the engine during operation to monitor the vibration levels to ensure the engine is performing optimally and in good condition. Available research literature about valve failures indicates that valve design is a complicated task because the valve is subjected to various loads at any point of time and can experience defects, especially cracks. Thus, it was decided that this project will monitor the vibration signals of these cracked valves under operation. Next, now let's look at the project's methodology. This project focuses on the engine valve crack fault in a gasoline engine, which can affect the engine's performance and also increase the vibration levels. The valve vibration levels under normal operation and correct operation will be monitored minutely. Vibration signal analysis and statistical analysis will be carried out to monitor and analyze the vibration signals of the valves during engine operation. The sensor that will be used to measure these vibrations is the piezoelectric sensor, which will then be processed through MATLAB software. The process data then was used for comparison. The project's experiment flows through 10 steps, which are number 1, start, number 2, literature review, number 3, experiment test setup, number 4, transducer setup, the next is signal measurement, the next is signal filtering, and the next is signal analysis, where if it fails, it returns to signal measurement, and if it succeeds, it goes into result analysis and comparison. And the next step is conclusion, and finally the end. The equipment that would be used in this experiment are 4-stroke gasoline engine, data acquisition device or DAQ, piezoelectric vibration sensor, Arduino Mega 2560R3, and a laptop programmed with MATLAB and LabVIEW software. Finally, let's look at the project's preliminary findings. Through the research for this thesis, it is found that the engine faults are common. These faults in turn leads to major problems on the engine. Engine vibrations contribute to this factor also. And one of the major faults that cause engine vibration levels to increase is valve cracks. It is expected that the vibration signals of the valves under normal condition and crack condition will be measured wirelessly during the engine operation, and the MATLAB software would be able to analyze the collected data to predict the outcome of the cracked engine valve in the future through machine learning and statistical signal analysis. A 4-stroke gasoline engine will be run under the cracked valve and normal valve condition at 3 different speeds. Problems during the signal analysis stage may arise due to the signal measurement being defective, as the piezoelectric vibration sensor could be attached wrongly on the engine. Another factor that contributes to the problems in signal analysis is wrongly setting the signal filtering. These two factors should be corrected diligently. Thank you for listening to my presentation.